Welcome everyone. A good portion of the chemistry deals with calculations, either with or without the aid of a calculator. For all of the problems that we will study, there are two different components. There's a chemistry component and the math component. Most of the first 8 chapters in this class are devoted to the review of or understanding of the chemistry component of the problems. However, in this particular chapter, I would like you to recall some of the important math skills. And if you haven't done those math skills prior to this chapter, then I strongly encourage to master this chapter. As you will work throughout these problems, you will apply the same critical thinking process in the upcoming chapters. In this chapter, we will study the use of significant figures, scientific notations, and most importantly, what is called as dimensional analysis. So the term dimensional analysis, let me write down the term dimensional analysis. You will hear me refer to this a lot throughout the course, and especially in the first 6 or 5 weeks. And I really want you to understand this within this chapter, as we will be applying this process throughout. Even if you can solve some of the mathematical problems or some chemistry problem without using this, you still have to learn this, because I want to see the application of this process as we go along. So firstly, why are we studying this? The process of dimensional analysis is best studied with the concept of measurements. Why is measurement so important? The reason for that is measurement provides data for any scientific approach. For example, if you have a fever and you just feel like your body is feeling warm, it's not going to help the physician unless you actually get the body temperature, and tell what the body temperature is. If you have to be prescribed a medication, then it's very important for the physician to know your age and to know your body weight, because many medications are prescribed based on these measurements. So in this chapter, we'll study the different units of measurement and when do you measure these. There are all kinds of different attributes that you can use to measure, and different things that you can measure. For example, you can measure energy, you can imagine the speed of light, you can measure velocity and speed, and conduction speed, and so a lot of different things. However, we will focus on measuring height, finding time, temperature of an object, and the weight of an object. So we're looking at these different properties only within this chapter. Here you can see a little approach that I just picked up online, and you can see that pretty much you use the measurement in your everyday life all the time. Whether you're filling up a gas station or you're driving a distance, you always want to know one detail or then the other. So in chemistry, as I said, we will use measurements to measure quantities of elements or compounds or products that are formed. Many experiments are carried on, and I will have you do some experiments during the lab portion of this class. And in the lab portion of this class, you will be asked to measure for mass, volume, and density, for example, or length, for example. And all of these have to be measured, and we will use what is called as the number followed by a unit. For example, if I ask you to go and measure 5 ml of a liquid, then it should be written as 5, which is the number, and ml. So never will you just write down the number without giving the unit next following that, because without the unit, the number has no sense as to what is the weight of that number. So always remember that whenever you report numbers in any of my lab experiments, I will take off points if the units are not present. So the units are a must. We use the measurements sometimes to compare different results from different experiments or compare different concepts. So we need pretty much a sense of understanding all of this concept, and this is a very essential tool that will be needed. So for example, in this picture, you can see this nurse. I'm assuming she's a nurse in an office, and she's trying to measure or fill up the syringe, and she using the number, which is how much of the volume should be used, and also the unit, because if she's taking milliliters or liters or centiliters, she's giving a different amount. So it's very important to write down the number followed by a quantity. Now, there are two main systems of measurement that are used. One is called as the American system. The American system is the one or that you're more familiar with, in which we say, for example, a pound is 16 ounces, or there's so many, like a yard is 3 feet. These are all American system, or a foot is 12 inches. So these are your American system that you're familiar with. However, the rest of the world is using the metric system, or sometimes it's also called as the SI, or the Standard International System. What is the beauty of this system is that this system is based on the factor of 10. So you have 10, 100,000, 100,000, million, and so forth. You always have, and then you can have 1/10, 100th, and so forth. So whether you have large quantities or whether you have small quantities, the difference between one unit is always going to be a factor of 10. This system is used worldwide. So, for example, if you were to take a road trip to Canada or Mexico, you'll find that these systems are used over there. And besides that, in scientific research, we always use the metric system. So within the lab exercise that we will do, you will never measure in inches or in feet or in ounces and so forth. You'll always be using the metric system. Now, there are different measurements that we can be dealing with. As I mentioned earlier, we will only be focusing on these 5 within this chapter. That is length, volume, mass, time, and temperature. So these are the 5 measurements that we will learn. In the metric system, the base unit is a meter. By the term base unit, we mean is that the base unit can be either enlarged or decreased. So for example, if my base unit is meter, I can put a prefix above that to enlarge the unit and call it the kilometers. Or I can use the prefix before which the prefix will sort of decrease the base unit. And we'll talk a lot about these prefixes, and you will have to know some of them. But this is what the base unit is. So for example, volume, the base unit is liter, and it can be increased or decreased. Similarly, mass is gram. Time, for amazingly, it's always the same, so we really don't have to worry about it. It's 60 seconds, and we have the traditional time. There's no difference in the time measuring in either systems. And the temperature, notice we're using the Celsius, which was formerly called as the centigrade in the metric system, and in the SI, it's Kelvin. So I will go through the SI unit over here to just show you the difference. The major difference are in the volume measurement and the mass measurement. The volume in SI is assumed that it could be a volume of a room or an object or a solid object, and we use cc or cubic meters for that. But 1 ml and 1 cc is equivalent, so it's sometimes we will use one or the other term. The base unit is kilogram instead of a gram, and the temperature is in Kelvin. So just minor details, but important enough for you to know. So now let's look at the length measurement, as how do we measure length in the metric system. Length is measured by a scale that is called as a meter yard or meter stick. And a meter stick is, as you can see from this image over here, here's your yardstick pointing out, and you have the meter stick on the top. You can see that the meter stick is slightly longer than the yardstick. The yardstick would probably end here. I'm sorry, I can't come up with a straight line using these virtual pens, but it's slightly larger than 36 inches. And to be exactly correct, the value is a meter has 39.4 inches. So it's larger than a yardstick. And if you, here is another image that compares centimeters to inches. Notice that the division of the centimeters are very fine. So for example, if I was a manufacturer of certain nuts and bolts, and my factory was to send orders to Mexico, if I was to use the inches or the American system, it may not be very accurate. However, if I use the metric system, I can come up with exact accurate measurement or to send for my order. So because of the finer values that you see, or the final divisions, I should say, in the metric system, it makes it much more accurate to be used. Another one that you will notice over here is a comparison between an inch to a centimeter, and 1 inch is 2.4 centimeters. So these are two values that you should know for the class and for the test. However, later on I'll show you the ones that you should know, but these are the two that you should know, one or the other. Okay, now let's look at the volume measurement. The volume, for example, can be measured using either a liquid, and we use the unit of liters. However, if you use solids, we use the meter cube. So if I have a wooden box that I have to take the volume of, then of course I will have to take length time width time the height, and that's why you will be expressing it in meter cube or centimeter cube. However, if I have to take a volume of a liquid, for example, in this graduated cylinder, I will use the base values of liters, whether it's milliliters, centiliters, decaliters, and so forth. Volume as a definition is given to a space that's occupied by a substance, and as I said, it could be liquid or solid. Something to note over here is a liter is equivalent to 1.057, and you could mention it as 1.06. It's okay for you to round that off to the second decimal place. So that is 1.06 quarts. The last one we want to look at is the measurement of the mass. A mass of an object is the quantity of material it contains. For example, if you were an astronaut and you went up to the moon or some other planet, your mass is going to be the same. However, for example, your weight on moon would be 1/6 of the weight. The reason is weight is defined in physics as mass times gravity, and mass is just the material that you have. Since weight is based on the gravity, so the gravity on moon is less, and that decreases your mass. However, your weight would be the same. So a lot of times when we use the word how much do you weigh, in general, our analogy is that you're actually talking about the weight, the mass. But you know, we sometimes switch between the terms all the time, mass and weight. For scientific reasoning, it's important to understand that mass and weight are two different things. But yes, we will be using the term mass a lot in this class. The mass of any object in the metric system is gram, and in the SI is the kilogram. And lastly, we have over here is the time measurement. The time is always measured. Sorry, this is not. This is the temperature measurement. I was going. I was moving, looking at the other slide on the side of my computer. The temperature measurement is based on either Celsius or Kelvin, and we will go into the details of both in the chapters later on. And I'll give you the formula to convert from Celsius to Kelvin, or Kelvin to Celsius, or Fahrenheit, and you don't have to memorize those formulas. I will be providing you. Temperature of a substance is an indication of how much heat or is present in that object, so whether it's cold or hot. Now we come to the last one, and that is the time measurement. The time is measured in seconds, so we still have the same thing. 60 seconds will constitute a minute, and 60 minutes will constitute an hour, and it's based on the atomic clock, and it's the same values that you are already familiar with. So I'm going to quickly end this over here, and then we will see you in the second second lecture of this of the series today.